we have just formulate how we will use this perturbation theory to calculation in different kind of system. So we have done with the matrix method. Now we will actually use this thing in some different type of system. So first we will going to use all different kind of perturbation into particle in infinite box. So let's go for it, and then we will go for harmonic oscillator. So only non-degenerate part, we have only this kind of situation, and everything will become into degenerate part. So now, what is the idea? Idea behind the perturbation is all about, you know, the eigenvalue and the eigenfunction of unperturbed system. You know the perturbation, and it is, you have to make sure that this perturbation is very small, such that it will not disturb the actual original eigenvalue and eigenfunction. Means you have the same system, means it is harmonic oscillator, but it will remain same, but little bit parameter can be changed. So why we have keeping lambda is very small, and then using the result of unperturbed Hamiltonian, we will use to get it what is the correction due to this small changes, or this is the small perturbation. So let's go for each and everything from the particle in box, then we will go for harmonic oscillator. So let's quickly go for basically particle in box, and you will see we need not to calculate anything. We know all calculation. This is the beautiful part, because we have done all this calculation very nicely into our core course. So we will just use this concept here, and we will quickly give the answer. Let's go for this. So a potential Vx is equal to 0, where x is between 0 to a and infinity otherwise, is perturbed with potential Hp is equal to lambda v naught, where x is between 0 to a and 0 otherwise. What will be En1 and psi n1? And obviously, if you will calculate psi n1, you can calculate En2 also. So this is the simple thing we have to calculate. Now, please, this is again one more thing. The examiner will never tell you that this is your particle in box. You have to identify, yes, this is my particle in box. And then once you will identify the unperturbed system, then you have to get the energy eigenvalue and eigenfunction, and we know what is the energy. So which kind of perturbation is there? So if we want to see, this is nothing but particle in box 0 to a. What we are doing, this is unperturbed, we are just changing the base level such that this will be something like this. Okay, so we are just changing the base level, so we are shifting the base. That base will be some constant value. So let's try to figure it out. What will be En1? So just go for En. So what will be psi n1? Can anybody tell me? What is psi n? Sorry, what is phi n for this system? That will be root 2 upon a sine n pi x upon a. Very good. And this will be between 0 to a and 0 otherwise. And what will be En? En is equal to n square E naught, and we know what is E naught. E naught is equal to pi square h cut square upon 2ma square. So I am just using this one. Yes, because I identify this is nothing but the infinite box of width 0 to a. And suppose if it will, suppose it will change to v naught, and this Vx is equal to 0, where x is between minus a by 2 to plus a by 2 and infinity otherwise, then how it is going to change? Then how it is going to change? This is also particle in a box. How it is going to change? Then you have phi n is equal to cos and sine. Remember? N is equal to 1, 3, 5, you have cos function, and n is
Yes,
equal
sir.
to 2, 4, 6, you have sine function. Remember, we have done this.
Yes,
Yes,
sir.
sir.
So don't forget all the theory what we have discussed. Okay, so you have to revise this thing. Now, so let's go for En1. This is nothing but phi n W phi n. And what is W is V naught. So this will be phi n V naught phi n. What will be this value? Without calculation, we can tell. What will be this value?
Lambda.
Lambda 0.
We know.
This will be integration 0 to a, and this will be 2 upon a sine square n pi x upon a dx, and v naught will become outside. That's it. This is the same thing, isn't it? If you are writing it phi n star v naught phi n, that is the same thing. What will be this integration? No need to do this integration. What will be this one?
1, sir.
1. This value is 1 because it is normalized. So this value is v naught. That's it. En1 is equal to v naught. Okay. So simple. So whatever we have calculated, you please try to recall and use into this particular calculation. Okay, let me go for next one. What will be psi n1? So कहाँ लिखूं? यहाँ लिखता हूं. So let's go for psi n1. What will be psi n1? How you will write? You will write the formula. M is equal to not n. Here you have phi m w phi n, and here you have en0 minus em0, and here you have phi m. Now in split you have to put w as v naught. So this value is equal to m is equal to not n phi m v naught phi n, and here it is en0 minus em0 phi m. So this is constant. Constant will operate on phi m or phi n. It will give you same thing, and you can take it outside. So what will happen? This value is equal to m is equal to not n. You can take v naught outside, phi m phi n, and you have en0 minus em0, and this value is phi m. Now what is this value? Can anybody tell me? M is not equal to n. What is this value?
0.
0.
0.
Because they are orthogonal, isn't
Yes,
it?
sir.
They are orthogonal. So this will be 0. So there is not any correction into first order if you have constant perturbation. So similarly, what will be En2?
0.
0. Because that is the same formula you are using. So this will be 0. That's it. So this is the answer. So what will be answer? The answer is En is equal to En0 plus lambda En1, and this will be, what is En0? Is n square E naught plus lambda n2, and this is V naught. That's it. This is correction. सिंपल, स्ट्रेट फॉरवर्ड, नथिंग टू डू. मैंने एक भी इंटीग्रेशन नहीं किया है और ना ही करूंगा. डोंट वरी. बिकॉज आई नो ऑल द रिजल्ट. प्लीज म्यूट कर लीजिए, किसी का ऑन है ना? Let's go for next one. So now I will just give you 3 and 4 perturbation directly, and we will just talk. We will just calculate it directly. Okay. Now I am taking the same system. Now the first perturbation is, this is first question, that HP is equal to lambda V naught, where X is between 0 to A by 2 and V naught by 2, that will be A by 2 to A. So this is first one. Second one, HP is equal to lambda V naught X upon A, where X is between 0 to A. Third, HP is equal to lambda delta X minus A by 2 A, that will be some V naught is there, lambda into A is also there. Okay. So this is the 3 question we are going to solve back to back. Now the first one. So first one, what is the value? So we have to calculate. So each and everything we have to calculate En1. In each case, we need to calculate En1. En1 is equal to what? In each case. So let's go for first one. Very simple. And all this question can come into your exam. So first one. En1 is basically phi n w phi n. Okay. What is phi n? This is nothing but the particle in box. So this will be, and particle in box of width 0 to A. So that will be same function. So there is not any problem. So let's go for En1. So En1 is equal to 0 to A. Phi n is equal to, you have 2 by A sine square n pi x upon A. Sorry, this is A 0 to A by 2, and here is V naught, plus you will just go for next integration is V naught by 2 A by 2 to A, and here is 2 by A. आ जाएगा. That is all about sine square n pi x upon A dx. दिखाई दे रहा है क्या? Are you getting this thing?
Yes. Yes, sir.
Okay. So please tell me what will be this integration? Dx is also there. I am writing it again. Don't worry. En1 is V naught. The first term is 0 to A. 2 upon A. Sine square n pi x upon A dx, plus second term is V naught by 2 0 to A by 2, and this is A by 2 to A, 2 by A sine square n pi x upon A dx. Now just tell me, this is little bit much better. What will be this value without calculation?
A by 2
1
1.
Two
Half.
आएगी sir. Two आएगी.
सर वी नॉट बाई 2
हाफ आएगी सर वैल्यू
half
पिटाई लगेगी
Half,
बहुत
half.
तेज, है ना? बहुत तेज पिटाई लगेगी. ठीक है? This is half. What is this? This is nothing but the probability to find the particle between 0 to A by 2. What is that? Half. 2 होगा, 1 होगा. This value is half. So this value is equal to V naught into 1 by 2. What is this value?
Half.
Again,
1/2.
half. So this will be V naught by 2 into half. So that value is V naught by 2 plus V naught by 4. So this value 3 V naught by 4. This is the answer. ऐसे करोगे? हाँ? So so are you comfortable with this one? So first order energy correction is 3 by 4 V naught. So let's go for second one. So I have done this one. Very simple. So let's go for second one. So what will be this? Again, we have to go for E1N1, and then this is phi n W phi n. What will be this value? You will just go for integration. This V naught by A will come outside, and inside this integration, you have X and 2 by A sine square n pi x upon A dx 0 to A. What is this value?
A by 2.
This value is A by 2. Why it is A by 2? Because you know this is the expectation value of X, and this is nothing but what? A by 2. So this value is V naught by A into A by 2, and that value is V naught by 2. No need to do any calculation. Are you getting this? Okay. So let's go for next one. Last one. So what is this? We have HP is equal to, so again we have to go for EN1. And what is this? You have to just go for phi n W phi n. So if you are going to integrate, you will have 2 upon A into A is there, and you have integration 0 to A, and you have delta x minus A by 2, and here is sine square n pi x upon A dx. I will take 2 by A outside, and V naught is also there. So this and this will cancel. What will be this value?
Sine square n pi by 2.
Very good. So this value is equal to 2V naught sine square n pi by 2. What is value of? Then this value is equal to 2V naught when n is equal to 1, 3, 5 and so on. And this value is 0 when n is equal to 2, 4, 6 and so on. Isn't it? So there are two value can be possible. So if n is equal to 1, 3, 5, this value is 2 naught, 2V naught. If n is equal to 2, 4, 6, then this value is 0. Isn't it? Are you getting all this thing? Okay. So let's go for next problem. Are you comfortable? Can anybody tell me of?
Yes, sir.
Okay. Okay. So let's go for next problem. So problem solving method, you have to be fast. You have to fast because we have done all these type of calculation. Now, let's go for different system. So Vx is equal to half m omega square x square, where x is between minus infinity to plus infinity, perturbed with Hamiltonian lambda x. Find E n1 psi n1 E n2. Everything we will find. So what will be energy eigenvalue for this? What will be energy eigenvalue? En is equal to n plus half h cut omega. And what is phi n? Is all about n ket, isn't it? You know this number ket. And what will be your x? This is perturbation. What will be your x? If I am using n ket, what will be this x? This x is h cut upon 2m omega. Remember, a plus a dagger. We have done this thing into harmonic oscillator. So what we will do, we will just try to solve this thing in a operator method. Because we don't know, because if you want to solve into Schrodinger notation, then you have to use all these particular Hermite polynomials. So it will be very difficult to solve this problem into Schrodinger notation. So what we will do, we will just go into Dirac notation and change the thing according to our convenience, and we can solve it. So let's go for this. So E n1, that will be phi n x phi n, and you have n ket a plus a dagger n ket, and you can take, and I am just writing this thing as x naught. Okay, x naught a plus a dagger. So this will be x naught is there. What will be this value?
0.
0. That's it. 0. Because you know a will operate on n minus 1, n and n minus 1 is 0. A dagger will operate on n. This will n plus 1. N and n plus 1 is also 0. So there is not any correction into first order. This is very interesting. This is ultimate. And let's try to figure it out. What is going to happen? Are you comfortable up to this?
Yes, sir.
Okay. So we have done. Let's go for psi n1, and E n2 you can calculate yourself. So I will just go for psi n1. Now this will be m is not equal to n. Here you have to write phi m w phi n, and here en 0 minus em 0. Here we have to write phi m. Now what is w? W is x naught a plus a dagger. So this will be, I can take x naught as common, and here is m is not equal to n. Phi m is m kit, w is x, and this will be n kit. And here we have en0 minus em0, and x naught is not right now. We will just go into next step. So let's go for this one.
सर 5 MB आएगा.
5 MB आएगा. So this will be m kit is there. So let's go for calculation all this thing. So what will happen? X I can write as x naught. So x naught I can take outside. We have phi m. X can be written as a plus a dagger n, and here we have en0 minus em0, and that will be phi m. Please mute कर लो, है ना? कोई बात कर रहे हो, बहुत ही ज्यादा डिस्टरबेंस हो रहा है. Please mute yourself. किसके यहाँ से आवाज आ रहा है?
पूजा सर।
पूजा प्लीज म्यूट कर लो भाई.
सॉरी सर.
ठीक है. सो नाउ लेट्स गो फॉर दिस. सो अभी हम इसको नहीं ओपन करेंगे. वी विल ओपन इट व्हेन टाइम्स कम. सो दिस विल बी कैन बी रिटन एज द फर्स्ट टर्म इज इक्वल टू m a n and this will be en0 minus em0 and here m is not equal to n plus m is not equal to n. We can write m a dagger n and here en0 minus em0 and here we have phi m and here we have phi m. Now चलो अब हम कैलकुलेट कर सकते हैं. We can just calculate it. I am just removing all this thing. So main thing is calculation. Now please tell me what will happen. So this will be x naught is there. A will operate on n. What you will get? You will get root n n minus 1. So first term will be summation over m and I can take root n here and we have m n minus 1 and here we have en0 minus em0. Here we have phi m. The second term, a dagger will operate on get n. What you will get? Root n plus 1, n plus 1. So you will get root n plus 1 and root n plus 1 and you will get summation is also there. So there is summation m is equal to not n. Here is root n plus 1 phi m n plus 1 and here you have en0 minus em0. Now x naught I have taken it outside. Now here again you have m is not equal to n. Now m is not equal to n. So this term is going to survive only for which m? This term.
M equal to n minus
n minus 1. So this term will be survive for m is equal to n minus 1. And this term will be survive for m is equal to n plus 1 and all other term will be 0. Are you getting this thing?
Yes, sir.
All other term will be 0. So what will happen? This all term can be written as x naught I am taking here and this will be root n. Only one term is going to survive, that is n is equal to m is equal to n minus 1. So this will be root n en0 minus e n minus 1 0 and here is n minus 1. And second term is only going to survive for root under n plus 1 and this will be en0 minus en plus 1 0 and that will be here is also m and that will be n plus 1. All other term will be 0. Make sure. Yes or no? All other term is 0 because this is the basically m can be changing from all possible value. So you have to see where m is not equal to n and for which m is not equal to n this term is going to survive. And now what will be this value? En minus 1. Please tell me what will be this value? What is this value? This is x naught. Very good. This will be root n and this will be h cut omega and this will be n minus 1. What will be this value? What is this value? This value.
Sir, H cut omega 1 will reach.
minus h cut omega. This
Okay.
value is En is what? En0 is equal to n plus half h cut omega. En minus 1 0 is n minus 1 plus half h cut omega, and en plus 1 is n plus 1 plus half h cut omega, isn't it? So what will be this value? This value is minus h cut omega, and there is n minus n plus 1 kit. So what is the answer? And this x naught I can put is h cut upon 2m omega, and this value is root n by h cut omega n kit minus root n plus 1 by h cut omega n plus 1 kit. That's it. So this will be your psi n1, isn't it? A very nice problem. Are you getting this thing? So what will happen? En2. Can anybody give me answer? What will happen En2? If you can write this one, you can easily write this one. What will happen? This term will be squared, this term will be square, and this term will be square, and everything will remain same. So if you are going to calculate the En2, you will get the same kind of solution. So when you will get En2 means you are again same calculation. M is not equal to N, phi M, W, phi N, and this will be mod square. Here we have En0 minus Em0. So again you will write all this thing. Finally what you will get? You will get En2 is equal to h cut upon 2m omega, and you will just see that will be n square upon h cut omega and minus n plus 1 square upon h cut omega. That will be the answer. Sorry, n square, not this is n and this is n plus 1 because root n. So this will be root n square and root n plus 1 square. So this will be h cut upon 2m omega. That will be n upon h cut omega minus n plus 1 upon h cut omega, and this will be minus h cut upon 2m omega, and this h cut will cancel. So 1 upon minus 2m omega square. Okay, so this is the answer. You can easily solve it. Okay, just try to calculate this thing for x square. Let's say lambda x square. So just try to calculate with yourself En1 and psi n1 for lambda square. Just try to calculate with yourself. Okay, I will give it this thing into your exam. Okay, so are you comfortable up to this? So whenever the harmonic oscillator problem will come, what you will do? You will just go for the operator method and then you will solve it. Okay, so let's go for the finally hydrogen atom, the ground state of hydrogen atom without a spin. Okay, because we have talking about the non-degenerate, but once we will include the spin, this will be degenerate. So I am just talking about without a spin. So let's go for hydrogen atom. चलो देखो बहुत मजेदार है. So hydrogen atom in ground state is perturbed with potential a number, let's say V naught by A naught R, B V naught A naught square R square, C lambda Z by A naught, D lambda X A naught, E lambda L dot S तो अभी नहीं कर सकते because this is not a, so this will be the thing. चलो, let's go for this. How many question? 1, 2, 3, 4. 2 minutes. What will be ground state wave function? Psi 100. Can you know what will be ground state wave function?
1 upon root
1
4 pi.
upon pi a naught cube to the power 1 by 2 e to the power minus r upon a naught. It is given a naught is bore radius. Okay. Chalo. What will be first answer?
3 and R.
So what will be first answer? You have to calculate psi 100 and what is V naught? I'll take the lambda here. So take the lambda everywhere. So what will be this one? This one is V naught by A R psi 100. You can take V naught by A outside. So if you will take V naught by A outside, what is this? Psi 100 R psi 100. What is this one?
3
3
by
and
2.
R, sir.
This is expectation value of R, isn't it? On a ground state. So this is expectation value of R in a ground state. So if you will
3 by 2
calculate
and R.
it, then you will calculate V naught by A naught, and you have to calculate 1 upon pi A naught cube R into e to the power minus 2R upon A naught R square dr. And you have to also go for sine theta, d theta, and d phi. Anyway, 0 to 2 pi, 0 to pi, 0 to infinity. But what will be this answer? No need to calculation. What will be this answer? Expectation value of R. We have calculated
3 by 2 and
3 by 2 A naught. So V naught upon A naught into 3 by 2 A naught. We have done this thing. So this will be 3 by 2 V naught. No need to go into this. Why we will go into this if we know that what is expectation value of R and we have calculated this thing earlier. Okay. So let's go for second one. So first one is directly we will write 3 upon 2 V naught. What will be this one? Can anybody tell me?
3 V0, sir.
So second question, what is going to change? We have to just go for B is equal to psi 100, R square is here, psi 100, and this will be B naught by A naught square. What is this value? We have calculated earlier.
3 A0 square.
3 A naught square. So this will be V naught into 3 A naught square upon A naught square. So this will cancel. This will be 3 V naught. What will be this value? रिवीजन नहीं किया, रिवीजन करने के लिए मैंने कहा था ना, जस्ट गो एंड रिवाइज हाइड्रोजन एटम. What will be this value?
0, sir.
0. So you will just go for lambda is there. So you will just go for 1 upon A naught you will just write 1 0 0 Z 1 0 0. What is Z? This will be 1 psi 1 0 0. You will R cos theta, and this will be psi 1 0 0. You remember what will be this expectation value? We have done. Everything is in your notes. What is this value? 0. This value is 0. So expectation value of this one is 0. Similarly, what is this value?
0.
0. चलो एक क्वेश्चन देते हैं, इसको करके दिखाओ अभी मुझे. If the hydrogen atom is perturbed with potential x square plus y square, let's say v naught upon a naught square, just calculate what will be energy in the, what is the energy in the ground state. Just calculate it and give me answer.
Four V naught, sir.
Very good. So what you have to do? So you have to just calculate, and lambda is also there. So we have to calculate psi 1 0 0 v naught upon a naught square x square y square v naught upon a naught square, isn't it? Sorry, this will be psi 1 0 0. So you can take v naught upon a naught square outside, psi 1 0 0 x square psi 1 0 0 plus psi 1 0 0 y square psi 1 0 0. What will be this value? We have calculated earlier.
2A naught square.
This value is a naught square, not 2a naught square. This value is what? A naught square. So this value is v naught upon a naught square. What is this value? This value is also a naught square. So this value is equal to 2v naught. That's it. Isn't it? So always be smart. If you are not smart, doing unnecessary calculation, then you are out of the race. Okay? Only doing calculation is not important. You have to also save your time. So how you will save your time unless until you are not going to do all the calculation and you are not going to remember all the calculation we have done earlier. So this perturbation is a method, but actual thing we have done ourselves. Each and every question, if you will go and revise it, your hydrogen atom, harmonic oscillator, particle in box, each and every calculation is there. Each and every calculation. So in the perturbation, you need not to do any calculation. What you have to do, you have to apply the actual thing at the suitable time or suitable place. Okay. So this is all about, you can see how many questions we have solved in just within of 45 minutes. So this must be the approach, and don't unnecessarily waste your time to solving unnecessary thing. Once you solve into particle in box, use it everywhere. Once you solve into hydrogen atom, use it everywhere. Once you solve into harmonic oscillator, use it everywhere. So now this is the first phase of perturbation. This is the simple phase, very simple. But the actual role of perturbation is in the degenerate perturbation theory, and that is most important thing we have to learn. So tomorrow we will finish the degenerate perturbation theory. So degenerate perturbation theory is all about the breaking the degeneracy, and you are able to get the what should be the use of perturbation into real physics. Okay, so tomorrow we will discuss the real physics. So we will just go for degenerate perturbation. So if you have any doubt, you can just ask me. Are you comfortable up to this?
Yes, sir.
Okay, so just go and revise your all problems. Okay, just go and revise your main thing, core thing. This is nothing but the application part of this. Okay, so we have finished our non-degenerate perturbation. Next class we will just go for degenerate perturbation. So same type of calculation will there, but little bit more physics is there. Okay, thank you.
Thank you, sir.
Thank you, sir.